Hey guys, welcome to my YouTube channel that is Algo Forces. So today we will be going ahead with this lead code problem. Lead code problem, it is 769, which is maximum chunks to make the array sorted. So what we will do is I'll go through the description and along with each line I will let you know about its meaning. Okay, so it says that you are given an integer array R of length n that represent a computation of integers in the range 0 to n minus 1. So it says that, like, if I take this example, so if I'm given an array of length 5, so it will contain all the elements from 0 to 4 in any order, in any permutation, right? Now it says that we have to split the array into some number of chunks, that is partitions, and individually sort each of the chunk. And after concatenating them, the result should be equal to sorted array. So let's say I am partitioning it like this: 4, 3, and 2, 1, 0. So it says that if I sort these two partitions, that is 3, 4, and it will give me 0, 1, 2. And if I concatenate them, it will be 3, 4, and 0, 1, 2. It should be a sorted array. But is it a sorted array in this case? No, right? So here the maximum number of partitions which I can make is 1, because if I sort all these elements, then only it can give me the sorted array. That is 0, 1, 2, 3, 4, right? You can also try to have some more combinations of the partitions, and you will later realize that we can have only one partition here. Okay. So let me take some examples so that I can explain you more clearly. Okay. So I'll just erase this board, and let's say I'm taking the example of 1, 0. Okay. So what is the maximum number of partitions here? Can I partition it like this? 0 to 0 and 1 to 1. 0 and 1 are the index here. Like 0 to 0 is from index 0 to 0, and 1 to 1 is from index 1 to 1. Can I partition it like this? No, right? Because it will give us 1, 0 only, which will be not sorted. But can I partition it like this? That is 0 to 1? Yes, because sorting this will give me 0 to 1, which is a sorted array, right? So the maximum number of partitions here will be 1. And we'll see why does this work. Because if we will sort this array, right, if we'll sort this partition, then it will make 1 at its correct position, and 0 also will be at its correct position, right? That is, 0 will be at index 0 and 1 will be at index 1. Yes, so comparing the element with index is working just because we are having elements only from 0 to n minus 1, so that if there is element 0, then it will be at index 0 by default, right? So that is why we can compare 0 with index 0. But now let's take the example of 0 to 1. Okay. So here we can see that 0 is already at its correct position. 0 is at index 0, and 1 is also at index 1. So if I sort these two arrays, it will give me a sorted array, that is 0 to 1, right? So this is the main observation which we need to realize, that if we make a partition such that the element comes at its correct position after sorting, that is, 1 comes at 1 and 0 comes at 0, which means that partition is valid. Okay, and we cannot have less number of partitions than the partition which we created already. So this is not possible. Okay, so now let's come back to the original example. So you can maybe pause this video, and you can maybe guess how many partitions can be made it here. Okay, so the maximum number of partitions here can be made like this. We can have only two partitions. Okay, so it will give me 0, 1, and this will give me 2, 3. So this is a sorted array. We cannot have the partition like this. We cannot have like this because it will give me 1, 0, 3, and 2, which is not the sorted array, right? Okay, so now why does this partition work? So basically okay, why does this work? Because it will take 1 at its proper index, that is 1, and 0 also will come at its proper index, proper position, that is 0. That is, 0 will come before 1. That's why this partition work. And similarly, in this case, because 2 comes before 3, 2 comes at index 2 and 3 comes at index 3. Now let's try to dry run. So initially I am at index 0. So I will ask one that will you contribute to the partition? So it says that if you will make a partition from 0 to index 1 such that so that I can come at index 1, that is at my proper position, then I will contribute. So we will mark partition index as 1 and we will mark number of partitions as 1 as 1 is contributing. Now the pointer comes here. 0 says that you have already made a partition from 0 to 1, and if you sort this partition, I will come at my proper position by default because I am already inside this partition. And I am, yes, so because I am already inside this partition, so that is why I will not contribute to the partition. Okay. Okay, now comes 3. Okay. So what 3 says that because I am outside of this partition, so I will contribute to the partition. So you need to make a partition from 2 to 3 so that I can be at my proper position, right? So the partitions will be 2 and the partition index becomes 3. Okay. Now again 2 comes, 2 is, so 2 says that I am already inside the partition. So we will be basically comparing I, that is the current position, with the partition index. So if I is less than 3, that is here 3 is okay. If I is less than or equal to 3, that is here 2 is equal to 3, right? So 2 won't be contributing to the partition. That's why we can have only 2 partitions here because 2 is already inside this particular partition. Okay, now let's take one more example. 1, 3, then comes 0, then comes 2. Okay, okay. So current partition is, one says that you need to make a partition from 0 to 1. Okay, sorry, not this one, from 0 to 1. Okay. Okay, now if we will update the partition. This is a different example. So I will start from the beginning. So here the number of partitions will be 1 and partition index will also be 1. Now comes 3. The pointer is at here. So 3 says that, okay, I am inside this partition, but if you will sort this particular partition, then I won't be at my proper position, right? So it says that instead of this, you should make a partition from 0 to 3 so that I can contribute to the partition. So here the partition index becomes 3. Okay. Partition index becomes 3 and it says that because I am not inside, I'm not, because the partition is not created in such a way that I could be at my proper position, so I won't be contributing and only the partition index becomes 3. Now comes 0, so it says that I'm already inside the partition and I would be at my correct position if you sort this array, so I won't be contributing. And also 2 says the same. So the maximum number of partitions here can be 1 only, right? Okay. So similarly, you can also see this example 3, then 2, then 1, and then 0. So here we can have only one partition from 0 to 3, and it will give us a sorted array. 2, 1, 0 won't be contributing as they are already inside the partition. Okay, I hope this explanation is clear to you. So let's jump to the code. So basically, I will loop through the array elements. And before that, we need two variables, that is partition count and partition index. Initially, the partition index will be -1 because there are no partitions created as of now, right? So now in loop, I will check that if the particular index is greater than partition count, sorry, partition index. That is, the particular index is outside the partition which we have created. So only in this case, the number of the partition count will increase. Okay. And if it is not outside the partition index, then we will do nothing. But since we have created a new partition by increasing the partition count, so we also need to update the partition index, and this will be the dot max of partition index and array of I, because we are taking max, because if 0 comes in this partition from 0 to 1, so we do not want to update the partition index 0, right? Because we do not want to decrease the length of the partition, so that's why we need to consider max here. And obviously we need to return partition count. Okay, so everything seems fine, so let's try to run the code. Okay, so it is working. Now I'll try to submit it. Great, it works and it beats 100% of total submissions. Okay, so here this is a final code, and I hope this explanation is clear to you, and this you have also understood this code. So please comment below if you have any questions, and I'll be there to answer all of them. Okay. So I hope you enjoyed this explanation, and please do like and subscribe so that I could be motivated to make more such videos. Okay, then bye bye.